So, hello, good afternoon, everybody. Welcome to our webinar today. The topic is the grid and system protection with Fronius inverters. We are here together I'm here together with my team colleague, Michael Brownick. He is in the chat. He will answer your question during this presentation. So feel free to send us your questions and we will answer them immediately. My name is Hans Pilzer. I'm doing this presentation, which will take about 20 minutes, 25 minutes, and then we'll come back to your questions. So what is it about today? Actually, we would like to start some general information about grid and system protection, then how it will work with the Fronius inverters. Then I'll show you the installation and commissioning on the Fronius main products, and finally the advantages of these systems. Good. Some general information first. What's a grid system protection? A grid system protection is a device which is measuring frequency and the grid voltage at the feeding point, and controlling and the PV power, or more or less switching off the PV power if needed. So if one of the voltage and frequency is out of the range. The grid and system protection disconnects the PV system fail-safe by acting on the interface switch. The interface switch can be a different contactor, for example, which disconnects the inverter from the grid and avoids islanding mode. So therefore, we have three variants. The first variant is the grid and system protection. So in general, for the three variants, we have normative requirements which are different from country to country. So we cannot tell you now exactly the regulations in your country. So please, therefore, we would like to ask you also to get in contact with your grid operators. So basically we have three variants, and I will show you the three variants in the next slides. We have an example here, which is from Germany. Germany is using these solutions for many years now, more than 10 years. It's the so-called VDA ARN norm 4105, and this norm specifies these grid and system protection of bigger PV systems. For the variant 1, we have for smaller installations in Germany up to 30 kVA, usually below about 30 kilowatt range. We can use the integrated grid and system protection in the inverter. So you don't need any external device for that. Just use the inverter, and the inverter is able to do that. Second variant is for bigger systems, more than 30 kVA. Here we need a central grid and system protection device. This can be from Bender, Thiel. There are many companies who are offering such solutions, and this device will be installed or has to be installed on the grid, the feeding point. Yeah, and then you have additionally the so-called interface switch, which is also in this case here on variant 2 as a central interface switch. So two conductors which are disconnecting the inverter from the grid. And both components have to be installed additionally. This is important. On variant 3, this is the variant where you have the advantage with the Fronius inverter as well, because here we use the integrated interface switch in the inverter as well. And this solution can usually be used in a certain range. Yeah? So this is depending on the country where you can use this, maybe up to 100 kilowatt or maybe even more. But this is depending on your country-specific regulations. And here you see that we have this grid and system protection device, external, but we have a cable to the inverter, to the interface, the integrated interface switch, and we disconnect here the inverter with this solution. So there you need no additional interface switch, so the interface switch is not necessary anymore. Yeah, to the functionality now, we have basically these three inverter types from Fronius can offer these solutions for commercial installations. The snap inverters from 10 to 27 kilowatt, the Fronius Gen 24, 6 to 10 kilowatt, and the Fronius Tauro inverters 50 and 100 kilowatt. All of these inverters have a specific input where you can connect these two cables from the grid and system protection device. On the snap inverters, it's a S0 input. On the Gen 24 and the Tauro, it's the so-called wired shutdown input, where you connect these cables, these two cables basically. First, if we start with the solution for snap inverters. On the snap inverters, you see on the left-hand side, the bottom, the bender NA protection or grid and system protection device with two conductors, K1 and K2, so feedback signals, which are giving a signal to the inverter, and you go via a power supply with buffering to a 24-volt relay. The 24-volt relay is then contacting these S0 input on the snap inverter. So when we get this signal, when the signal is off, then the inverter will also switch off. So in this case, you need here this grid system protection from bender, a power supply with buffering, and a 24-volt relay. And then you go with these two cables to the inverter. You can also have more inverters, then you just need another relay. For each inverter, you need one 24-volt DC relay, and then you go to the inverter. If you're using Gen 24 inverters, and for example, also one snap inverter, you will see that here you can also use the input from the Gen 24, which is in this case then the wired shutdown input. Yeah? So it's not the S0, it's the wired shutdown input. So you have to use this one. But also the 24 relay in this case would be required for each inverter, one relay. Another solution which makes it much easier is now with the only Tauro or Gen 24 inverters, so without snap inverters. So we're using the new inverter range from Fronius. For bigger installations, usually we use the Tauro 50 or 100 kilowatt. And here you don't need any additional relay. You just go direct from the grid and system protection device, in this case bender, with two cables to the first one, to the first Gen 24 Tauro inverter, to the input, and then from the output you go to the next inverter. And then you can have, of course, here up to 28 inverters in a row, and you can connect all of these inverters or many inverters and use the internal function of the grid and system protection of the interface switch. So this solution is, of course, appreciated. Now let's come to the installation. How do you, what do you need to install in the inverter to get this solution? Basically, first, the requirements, as I told you, observe the national regulations. That's important because they are different in your country, possibly. So get in contact and ask how to do that. If you can use the internal interface switch and you use a snap inverter, you need a 24-volt relay, and this has to be installed best in the inverter. On the snap inverters, you can do that because there is also a space for this relay on the DIN rail, and you have a space of 110 millimeters and a maximum depth of 66 millimeters for the relay. So usually a small relay can be integrated here easily. So please make sure that you fulfill these requirements when using this relay. And then on the snap inverter, you can see here on the picture, on the picture 3 on top, in on the wall bracket, you have on the right hand side on the Eco Sumo inverter space, the DIN rail, and here you would place the small relay, 24-volt relay. From that relay, you would then go with a cable to the S0 plug. This is here on the left-hand side. You can see in the picture below. Here you would connect that to the inverter. So basically, you get on input 24 volts from the grid and system protection device, and here with this output from the relay, you go to the S0 input with this cable. So this is not too difficult, but then you need also to do some settings on the display. You will need to set basically the code, basic code. Basic code is 22742. Therefore, press the button, the second button from right hand side 5 times. Enter the code 22742, and then enter, and then you have to select have to go to external signal, that you have an external stop with a normally closed contact. So these are the 3 settings you have to do. So you just go through the menu, and it will ask you first, what would you like to do? I would like to have an external signal. I would like to stop the inverter with this signal, and it's a normally closed contact, which is given. That means if the contact is closed, the inverter would run. If the contact is open, the inverter would stop. So that's what you need to do on the snap inverters. On the Gen 24 or Taro, it's much easier. You just have this wire shutdown plug. This is a 4-pole plug on the interface, on the communication card of this Gen 24 inverters or Taro inverter. So and you see here a bridge between in plus and in minus. If you take this jumper out here, this cable, and you then connect the GS protection device here with these 2 cables, then you have already the solution. So you don't need to do anything more than this. Just get these 2 cables on these 2 pins, and that's it. No special configuration required, nothing to do. If you have more inverters, more Gen 24 or Taro inverters, you will have one primary master unit and then the second slave units. You go with the cable to the first, from the grid system protection device to the first inverter, to the master, to in, plus and minus, and then use the cable from out and go with a 2-pole cable to the next inverter in. Then again, from the out to the next inverter in. So that's it, all what you need to do. And then, of course, as well, this small switch on top of the card has to be switched to off, to 0 position. Just the master is on, is at 1, and all the rest of the inverters has to be switched to position 0. That means that we know that these are the slaves, and the other one is the first one, the master, which is on position 1. But I would say here, quite easy, no configuration, specific configuration necessary. The inverter needs this contact here, and then it would run. If the grid and system protection switches off, all the inverters will be switched off immediately. And then you will get also a signal in SolarWeb that the inverter have stopped, and you get a state code displayed on the SolarWeb display. Now, a small special solution when you're using the overvoltage protection, surge protection device, and the grid and system protection, then you will need to put the feedback signal from the integrated SPD not to the wire shutdown plug, but then to the other plug, to the 16-pole plug on the right-hand side. Here you see these two pins, V plus and input 8. So we just get these two cables and take them here to this other plug. Reason is because we're using usually the wire shutdown input for the SPD, but in this case, of course, we would then not be able to differentiate between a failure from the grid and system protection device and from the SPD. So therefore, please separate that, and then you can get both different error or state messages whenever something is wrong. So the triggering of the SPD leads to a feed-in limitation. State code 1003 is displayed, and the wire shutdown error message is displayed with state code 1030. This means wire shutdown is triggered. The inverter will then be switched off completely. Yeah, here on the then when you have done these settings, you will need to also to configure the digital I/O, which is here digital I/O 8 is here configured as I/O power management with a feed-in limitation setting of 99%. Means here in this case we have only 1% feed-in limitation, so that's more or less a warning only. But you could also set this to 0%, then it would be 0 feed-in, and the inverter would more or less stop feeding into the grid. So also stopping. Whatever is required when the customer, when you would like to have the limitation down to 0, when the SPD has more or less an error, then you can also choose whatever you like to have. So we can also set 50%, for example, but we would actually recommend you to use the 0 or 99% feed-in limitation. Then you have the error message that you know there's something wrong with the SPD, and you will need to change the SPD. But you can do that also with 0 feed-in. Then everybody recognizes immediately there's something wrong, and you have to do something. Good. So these have been the solutions, and now I would like to go to the advantages of the solution again. With the Fronius inverter, you can use the integrated interface switch. So this helps you to avoid additional 2 main conductors in series. So it's cost saving, and also it's cabling necessary additionally. It works with all the Fronius inverters, of course, general with the bigger snap inverters with the Gen 24, but mainly the Tauro inverters, which will, of course, offer this big advantage of really easy cabling and commissioning. Yeah, and then the certificate from Fronius is, this has also been tested from an aggregated testing institute, the Bureau Veritas, and this gives you also the good, makes you ensure you that this protection works perfectly. Yeah, the cost savings can be up to 2,000 euros, depending, of course, on the country, on the conductors you need to use. I have to imagine 2 conductors for 100 kilowatt will cost also quite a lot of money, and then it's of course interesting to avoid this and use the internal interface switch. Also time and cost, of course, and you can also save space in the main distribution board. Yeah, that was it so far. Now, if you need more information, you can find in the documents one application guide which shows you how more detailed information about all that what I've shown you, explained you now. Also, you will get the webinar recording tomorrow, so you can watch that video once again if you want. And if you need more information, feel free to get to our webpage, www.fronius.com. Solar energy, you can find here for the specific countries, also information in your language. Sales information, please, to pvsales@fronius.com, and technical questions to pv-support@fronius.com. Yeah, good. I would say now we will have a look to your questions. So far, there are no questions. Good. Then I would say we stay online with you. Please use the time to send us your questions. We will answer them immediately. And if not, I thank you for your participation. Hope to see you once again to one of our next webinars. And stay healthy, and good luck and good evening. Bye from Austria. Bye-bye.